Okay, for example 4 of row integration by parts, let's look at the integral of the natural log of x cubed. RIP, or row integration by parts, is the tabular method for integration by parts with an emphasis on the rows. Each row represents an integral, and we proceed one row at a time. So if you haven't already seen an introduction to RIP, I suggest you pause this video, take a look at the intro video, which comes with a couple of examples, and then get back to this one later. Okay, so this one, you might think it's kind of bad, and in fact, let me show you the full solution here. Yeah, that looks kind of bad, except for the fact that we're going to proceed one row at a time, and by doing so, it actually won't take that long, and it's not going to be that difficult. So let me show you. Alright, we start off with 4 columns. We always start with alternating plus or minus signs, a column of functions to be differentiated, functions to be integrated, and a 4th column representing the integral of the product of everything in a given row. Always start with the plus sign. I'm going to choose to differentiate natural log cubed, and that leaves a 1 to be integrated. So notice that 1 times log cubed times a positive 1 gives us the original antiderivative. Okay. So we alternate plus minus signs. Differentiating log cubed using the chain rule, we get 3 over x log squared. Integrating 1, we get x, and we take the product of -1 times this function times the x. Right? So, look what happens, right? The x from the integral cancels out with the x in the denominator that came out of the chain rule. And in fact, we have a much simpler integral here, a much simpler product. We have negative integral of 3 log squared, and in particular, notice that the power of the log has dropped down by 1, so we've certainly made it an improvement. But what do we do next? Well, we definitely want to allow that cancellation to happen, because if we had to differentiate this function, we would have a product rule with the chain rule. It's kind of messy. So let's just integrate this instead. In other words, start over. I'm putting this horizontal line here to indicate that I basically am restarting a new integration by parts for this new integral. Okay, so let's rearrange the terms as follows. Take the 3 log squared, integrate a 1, differentiate a 3 log squared, and keep this minus sign in front because, well, it was there before. But also, we want to keep track of this integral. So the integral represented by the second row is the same as the integral in this third row, right? Except now, in this third row, we have a much simpler expression that we're going to perform the next iteration of integration by parts on. So let's see what it gives us. Alternate plus minus signs, a chain rule, integrating 1 gives us x. Take the product again, and again, the x from the chain rule is going to cancel with the x from the integral. And we have simply the integral of 6 natural log. So we do this one more time. Every time you integrate natural log, if you don't want to memorize the formula, it's a simple integration by parts. But notice that we want to allow this cancellation to happen, so we restart again. Okay, so rearrange, this time just having the 6 natural log of x represented as positive 1 times 6 natural log times 1. One step in, we get one more step in, I should say. Get a -1, 6 over x times x, and of course, once we integrate this product, it's simply the integral of -6, which is -6x plus a constant. So gathering terms to get the antiderivative of log cubed, we take a 1 times a log cubed, go down a row and pick up an x, but we don't cross this line, remember, because it represents the same integral, right? This second row and this third row are the same integral. So we don't want to cross that line. We don't want to combine terms from one integral. But we do want to take integration by parts on this integral, which we did in the third row. So then we pick up a -1 times 3 log squared times an x, and the last set of terms from the columns anyway are going to be a 1 times 6 log x times x, and the very last term is a -6x plus a constant, and we're done. Thanks for watching. Please subscribe to my channel, check out the playlist, and learn to master integration by parts.